So now in this video we're going to do really an introduction to electronics videos when it comes to the voltage divider. So we're going to cover most of what you will encounter in basic electronics. So here we have a fixed resistor voltage divider. So there's three of them. You may have two if they're equal values. Where they come together you'll have half of the power supply voltage. Here we have three. So there's a couple contact points. So that resistor goes to positive rail, goes to this resistor. This screwdriver is magnetic, and then it goes through that resistor to this point, which connects to that resistor to the negative rail. These are all 1 kilo ohm resistors, by the way. So the power supply sees 3,000 ohms of resistance right there, and so we can get 2/3 of the power supply voltage up here because it's closer to the positive rail than the negative rail, and then we can get 1/3 of the power supply voltage over here because it has 1/3 of the resistance towards the negative rail and 2/3 of the resistance towards the positive rail. We also have a trimpot. We can adjust the resistance, but it's the same thing. We have this jumper here that connects to a resistive element which goes across to this jumper. It's one resistive element of 10 kilo ohms right there. This is a 10 kilo ohm trimpot. They have trimpots of other values, but in any case you turn a wiper here, and the wiper is attached to a metal pin and it slides along that resistive element right there. So sometimes there's more resistance towards the positive rail, sometimes more towards the negative, depending on where you have it turned. But in any case, wherever that arrow is pointing is where the wiper is connecting, and it comes to that point. So if we go all the way up, we have 10 volts because that's what the power supply is. We go all the way down, we have 0 volts at this point compared to a ground, and anywhere in between right there. Then we also have the light dependent resistor we're going to look at. So by itself it's just a resistor whose resistance changes based on how much light is falling on it. So you'll commonly see it with a fixed resistor. So it's kind of like one of these fixed resistors with a varying resistance on the other side based on how much light is falling on there. And so quickly we're going to look at the power supply. It's important to note this whole video we're going to use 10 volts right there. And this power supply displays how much current is flowing through it, which is really nice. Plus we can limit current. I have current limited to 30 milliamps, and we're going to stay below that. But we can see the voltage as being output there, or the current. But there you can see there's current flowing even though nothing is going on. And that's because, as I said before, we have resistance from positive rail to negative rail for both of these. So it's probably actually 4 milliamps of current. This 3 here means 3 milliamps because that's the amp range. 1/10 of an amp, 100th of an amp, and then thousandths of an amp. And milliamps are 1/1000th of an amp, and there's 3 of them. And so this isn't as accurate as a multimeter, but it's close. But in any case, this is a 10 kilo ohm resistor. Probably 1 milliamp is due to this, but we don't see anything when I yank it. But I'll slide that in. It still said 3. If I pluck one of these resistors, now you see it goes to nothing. And so it doesn't even see the current going through the trimpot. But these are each 1,000 ohms. That's 3,000 ohms. So 10 volts divided by 3,000 is 3 thousandths, 3 milliamps, and a little bit more, 3.33. And moving along, the light dependent resistor is pretty straightforward. I'm going to take the probes there, and I got these alligator clips which I crimped jumper wires to, so I can easily clip them directly to the probes and then go across the light dependent resistor. So I'll put positive up there. Polarity does not matter, it's resistance in either direction, and turn the meter to measure resistance up there. I don't need to move the red probe, it takes everything but high current measurements from there, and there we can see the resistance with this amount of light. So close to 600 ohms. I'm going to kind of get my finger over that, and you can see now it's kilo ohms. So that changed to K ohms, so even though the number looks smaller, that's in thousands of ohms. And I'm going to, I think if, I didn't mean to hold it. If I turn the light off, I think it will automatically, there we go, the light automatically came on. So that's kilo ohms, 300,000 ohms. Put my finger over it, and you can see we're in the millions of ohms. It goes up really fast, and I turn the lamp on. The brighter the light, the less resistance. Let's get my headlamp, which is probably my brightest light, you can see we can get down into dozens of ohms. I think if I get it just right, I may, you couldn't see that, could you? There we go. I think, there we go, we got about 50 volts, 50 ohms right there. I think I can get it down to practically zero. So that's why you'll usually see me have at least some resistance in series with it at all times. So now, of course, this video is about voltage dividers, and we haven't even looked at voltages yet, other than the power supply voltage. So I'm going to take that jumper, which again is connected to that probe, put it there, and we can even measure the rail voltage. Right now, the power supply voltage, and you can see 10 volts right there. And so we come to this side of the resistors. So that's most of the way to the positive side of the power supply, about 2/3 of the way. And you can see 6.6 and then 66666 forever is 2/3. And that's because 2/3 of the resistance is towards the negative side, 1/3 towards the positive side. It's closer to the positive voltage. And we come here, and you can see now we are 1/3 of the way from the negative rail, because we're coming to this point here. So from a negative rail through the resistor to negative rail, it's 1/3 of the resistance compared to what's going to the positive rail. So you get 1/3 of the power supply voltage of 10 volts. Remember, we're dealing with 10 volts at the rail, and we did measure that. So pretty straightforward. We don't need 3 resistors. We can use 2 right there. And you can use however many you want if they're fixed, or we could have used a 2 kilo ohm instead of 2 1 kilo ohms, but then we would only have 1 voltage to deal with. But there you can see with 2 equal value resistors, we have half of the voltage. And we don't have to use these exact value resistors. It's just if they're equal value and there's 2 of them, you'll get half of the voltage. You won't be able to provide as much current if they are higher value resistors. And so that's something to keep in mind later on. But the main takeaway for this video, just simple voltage divider stuff, is with no load, the multimeter has a lot of resistance, so practically no current goes through it. It doesn't throw that voltage off. And so usually you want to use voltage dividers with something that looks at the voltage but doesn't need a lot of current. So now we're going to go to the trim pot. Trim pot's a lot nicer. And so we got that here. You won't want to use it if you know the exact value, what resistors to get, and you're never going to change it. But they are really nice, especially if you're going to change, and if you're really baffled what resistors to use. But there you can see we get closer to the negative rail, and we get a lower voltage. That's because we're connected directly to the negative rail there. That goes to that jumper, and then the other side through the meter comes to the negative rail. So negative rail to negative rail, there's no voltage difference. We turn it to the positive rail. Then we go directly from the positive rail to that jumper over to here. It's just like measuring the rail directly. And then we can add a little resistance on the positive side to lower the voltage a little bit. But it's not halfway yet till we get about halfway. And then we get more than halfway to the negative rail. We're closer to the negative rail. We're lower than half of the voltage. And down here we have an LED. So it's a blue LED. It's going to light up really nicely even with low current. Here is a 470 ohm resistor. This is close to the lowest value resistor you want to use to protect an LED, using 10 volts. And you can go higher, of course, no problem. You probably won't want to really go lower. So once I add the light dependent resistor, now you can see the LED lit up. So it's adding up the resistance of the 2 of them. And so if I can get it dark enough, we should see the LED get dim. Let's turn the light down, because the light can still get through my finger. But I think you can see there. Now it got really dim. Now it got bright. And let's try making it so the light's not as obvious. That even triggered the meter. But there you can see, resistance went up. So this is just series resistance lowering it. And if we got it dark enough, the LED would go out, because we saw earlier it had millions of ohms of resistance, and the meter is not even measuring that. I don't need that on. So now what we can do, we can still make a voltage divider out of this. This particular one is going to have the LED in it, but in any case, we can take the 470 ohm resistor and this will get hot at 10 volts, so I do have to be careful. And now we are going to take the light dependent resistor, or you could call it a photoresistor. So that's going where the resistor is, right there, and the anode, the long lead of the LED. You have to have the anode towards the positive side and then the cathode towards the negative side for it to light up. But there you can see it's really bright right now because the light is not terribly bright. So I'm going to turn that light up, and it still looks pretty bright. Let's get this light on the light dependent resistor. So there you can see the LED went off when we get enough light on there. That's because as the light dependent resistor has less resistance, it's pulling the voltage down. We looked at that earlier, and we can look at that again. Let's plug that into the same row there. And there you can see we got enough voltage. You need 3 volts to get the LED to light up, and then it's pulling the voltage down, holding it. But when I get the headlamp on there, you see it pulls down way below 3 volts right there, and about 1 volt right now. So it lowers the voltage until we pull away. And now, so right now it's pulling down. I said before, a load will pull down the voltage even more because it goes to the negative rail. That's something you got to be aware of in practical circuits. But now we're going to yank the hot resistor there, and I didn't burn myself or anything. It wasn't too bad, but it's better to turn off the power supply and let it cool down a little bit before you touch it. So now we're going to put the light dependent resistor to the positive rail and the fixed resistor to the negative rail. And so the better the light dependent resistor conducts, now the higher it's going to pull the voltage. And you just saw that when I blocked it with my finger right there, that the voltage went down. That's because there's more resistance now to the positive rail, and there's a fixed resistance to the negative rail. So the more resistance we put to the positive rail, the less voltage we will have. It's going to go down. As you can see, it went down below 3, and now it is at 3. And I can't really get it up higher. I can get it a little bit higher. More current's going through the LED. It's getting a bit brighter. It's blocking a little more voltage. But to get an accurate reading of the voltage, there we have about half. It's about 470 ohms. It looks like pretty close, which we saw before. And as I get more light on there, now the voltage goes up because we don't have the diode going to the LED going to the negative rail to pull it down. But there you can see right there, you can manipulate the voltage with the light dependent resistor, and which, if you want it to pull down under bright light, you put it towards the negative side. If you want to pull up the voltage under bright light, you put it to the positive rail, and you put the resistor on the opposite side of whichever ones those are. So, in any case, this video went on a lot longer than I expected. I hope you still enjoyed it. Thanks for watching. I will see you in the next video.